Hi guys, welcome to my channel. Today we're going to be looking at a challenging problem which is going to take multiple different techniques to solve, and it's also known as the storm chaser problem. So let's get straight into it. A car travels due east at 2/3 miles per minute on a long straight road. At the same time, a circular storm, whose radius is 51 miles, moves southeast at route 2/2 miles per minute. At time t equals 0, the center of the storm is 110 miles due north of the car. At time t equals t1 minutes, the car enters the storm circle, and at time t equals t2 minutes, the car leaves the storm circle. Find t1 plus t2 divided by 2. So to start this problem, we're going to draw a diagram, labeling in some of the information that we've been given. So the center of the storm is going to be represented by this blue dot, and the car is going to be represented by this red dot. And we'll call the starting point of the car the origin. So this can have coordinates 0, 0, whilst the starting position of the center of the storm can have coordinates 0 and 110. So we can express the position of these points in terms of t. So for the car, its y position is always going to be 0, since it's traveling due east. And since it's moving at 2/3 miles per minute, its x position is going to be 2/3 t. And for the storm, to start with, we'll just express its original position. So its center is at the point 0, 110, and it's got a radius of 51 miles. So to start with, its position is going to be x squared plus y minus 110 squared is equal to 51 squared. So in order to express the center of the storm's position in terms of t, we notice that it's moving southeast. Now, mathematically, this means that its coterminal angle is negative 45 degrees, or in other words, it's 45 degrees below the x-axis. And since it's moving at root 2/2 miles per minute, this means that every minute, this is going to be root 2/2. And if we draw in these two sides, we know that both of these sides are going to be a half. And if it's not clear why, notice that this is a right angle, and that it's also an isosceles triangle. So what this means is that the x-coordinate of the storm center is increasing by a half every minute, whilst the y-coordinate of the storm center is decreasing by a half every minute. So if we wanted to express the equation of the storm circle in terms of t, this would be x minus t over 2 squared plus y minus 110 plus t over 2 squared. And the radius will remain constant at 51. Now we are told that there are two times where the car enters the storm circle and leaves the storm circle. So what this implies is that at these two times, the position of the car in the storm is the same. So therefore, we can substitute in our values for the position of the car in terms of t into our equation for the position of the storm, like so. And this should give us both of the times where the storm and the car meet. So substituting this in, this is going to give us 2/3 t minus t over 2 all squared plus minus 110 plus t over 2 squared is all equal to 51 squared. Now simplifying the left bracket gives us t over 6 squared, and expanding the right bracket gives us t squared over 4 minus 110t plus 110 squared is equal to 51 squared. And then expanding this bracket will give us t squared over 36 plus t squared over 4 minus 110t plus 110 squared minus 51 squared is equal to 0. Now simplifying this, we get 10t squared over 36 minus 110t plus 110 squared minus 51 squared is equal to 0, or 5t squared over 18 minus 110t plus 110 squared minus 51 squared is 0. Now finding the roots of this quadratic looks pretty nasty. However, we are told that we only need to find t1 plus t2 divided by 2. So this means that we can use Vieta's formulas. Now Vieta's formula tells us that the sum of the roots, which we'll call t1 and t2, of a quadratic is equal to the negative coefficient of the linear term divided by the coefficient of the quadratic term. Now the negative coefficient of the linear term is going to be 110, and the coefficient of the quadratic term is 5 over 18. So this is going to give us 110 times 18 over 5, or 22 times 18. Now we only need to find t1 plus t2 divided by 2. So this is going to be equal to 11 times 18, or 198. And this is our final answer. So how did you find this question? Let me know in the comments below. If you enjoyed this video, please like and subscribe and share it to a friend to see if they can solve it too.